All right, so we're looking at dividing polynomials, the remainder theorem, and the factor theorem. All right, so let me erase some of this so we can walk through the process. So we're looking at the regular long division process. You guys have been exposed to it before. We're just talking about numbers, taking them, dividing them out. And so I have 5,867 divided by 11. Notice you put the 11 on the outside of your long division process or long division bar. And on the inside, we put the 5867. So recognize that 11 doesn't go into 5, but it goes into 58 5 times. Then you take this 5, multiply it times the 11. That'll be 55 right here. Now we're going to subtract the 55. 58 minus 55 is 3. Then you bring down that 6. So you ask yourself, how many times does 11 go into 36? And that is 3 times. 3 times 11 is 33. Subtract 36, 33 from 36, that'll give you 3. Bring down the 7. 11 goes into 37. 3 times again. 3 times 11 is 33. Subtract those, and that'll give you 4 as a remainder. So the last value here is remainder. And this is how you will write that answer. So it's 533, and then you put the remainder over what you were dividing by. So that is your long division process with just numbers. So we're going to replicate that process with polynomials. We're going to do the exact same steps, but we're going to use polynomials. All right. I said something. Scroll up. Are you talking about down or further?
I think she missed the upper part, the remainder theorem and the factor.
Are you talking about this part?
Yeah, I think that's what she missed.
Mm-hmm. Mm-hmm. Yeah. Yeah, you should have said scroll all the way up, then I would have had you.
I'm kind of eating my lunch, so that I missed.
Oh.
I'm sorry.
It's all good.
I had a class before that, and I didn't have a chance to eat.
It's all good. All right.
Professor Tucker.
Yes, sir.
So test 3 is going to be like where you're going to watch us?
Yeah. Yeah. Or, let me think about it.
All right.
Because I haven't decided if we're going to do a fourth test or just have that final exam as our fourth test. Let me ponder how we're going to do this.
All right. I'll ask you like in the next few classes.
Until I give you the answer.
I just like to know so I can prepare myself for the test, like get my notes done and everything.
It's all good, sir.
Yes, Mr. Coley.
Kill the move.
All right. Are we ready to go up? I know we had one person that was making sure she had her notes straight. We good? All right. I think I'm okay. Not saying anything. All right. So let me erase some of this stuff down here so we can walk through the process. I erase all this. All right, so we want to divide, and I can put this right here, separate that. So we want to divide x squared plus 10x plus 21 by x plus 3. All right, so just like when we had the 11 and the 55, 86, whatever that number was, you take the divisor, put it on the outside, dividend, Put it on the inside of your division bar. So that's your setup. And so now we're going to compare the first terms in each, x and x squared. You want to know, either ask yourself what times x will give you x squared, or how many times is x divided by x squared. So that's the other way you can do it. X squared divided by x gives you x. And so that is going to be the first part of your answer. What times x will give you x squared is going to be x. Now, normally you line it up with the same exponent of your variable, but it really doesn't matter because all of this is just the space for your answer. But once again, normally they line it up x over x when you're talking about putting in your answer. All right, so x times x will give me x squared, so that's where this x comes from. Then we're going to multiply it to both of these terms out here. Same thing we did with the long division process with just numbers. So x times x will give you x squared. X times 3 will give you 3x. Now, this is the part that you most definitely have to be careful on. Where a lot of people make a mistake is that they'll subtract x squared, but they don't subtract this other term. So that minus, or that subtraction, not that mean to do that. That subtraction has to be applied to both terms, the x squared and the 3x. So x squared minus x squared will cancel. 10x minus 3x is 7x. So like I said, make sure you don't forget to subtract this term. A lot of people make that mistake. Bring down your 21. So now you're saying how many times does x go into 7x? Or in other words, what times x will give you 7x? So we have right here, of course, that's 7. So plus 7 up here. 7 times x is 7x. 7 times 3 is 21. And subtract both of these. They end up both canceling. And we have a remainder of 0. Since our remainder is 0, our answer is just x plus 7. All right, questions before we do another one? All right, we're done with that one. Can I scroll all the way up?
Professor Tucker,
Yes.
I have a question.
Mm-hmm.
Can you scroll back up?
Yeah, hold on a second. Uh-huh.
You just can't plug that x plus 3 underneath there. Then once you get your answer, factor it.
That only works, or that may only work. Still have my eraser on. If your remainder is 0.
Okay.
That may work. I see what you're trying to do. But that's because, and we're going to talk about that a little bit later. That's because x plus 3 is actually a factor of that. But that won't work when you have remainders that could occur.
All right. I just remember it from my old class.
Say again?
I remember it from my old class.
Yeah. But the reason why that is because your remainder was 0. But if your remainder wasn't 0, then that wouldn't work out well for you.
Thank you, Professor.
Yeah, not a problem. All right, let me erase this stuff just like before so we can walk through it. All right, so here we have 4 minus 5x minus x squared plus 6x cubed. I want to divide that by 3x minus 2. So first thing I want to recognize is that this is written in ascending order. It's best to write it in descending order. So that's why I just rearranged my terms. And, especially since this is in descending order already. So just go ahead and stick with the same process in which we write our terms in descending order. And you'll be all right. Let me erase this. All right. So once again, we're going to compare first terms in both cases. What times 3x will give us 6x cubed? Let me see right here. 6x cubed divided by 3x is 2x squared. Once again, lining up my x squared and x squared. This needs to be multiplied to both terms out here. 3x squared, well, 3x times 2x squared is going to be 6x cubed. Negative 2 times 2x squared, negative 4x squared. All right, do your distribution. And this negative right here is going to turn positive. So negative to negative turns positive. So that's going to be negative x squared plus 4x squared, which would be 3x squared. Bring down your negative 5x. Compare first terms in each once again. 3x squared and 3x. What times 3x will give me 3x squared? And that'll be x squared. Oh, not x squared, excuse me, x. X times both of these will give me 3x squared minus 2x. Distribute the negative. And I didn't cancel out my stuff here. Yep. So 3x squared minus 3x squared will cancel. This will be a plus 2x. So negative 5x plus 2x will be negative 3x. Bring down your 4. Then what times 3x will give me negative 3x? That'll be a negative 1. Multiply negative 1 times 3x is negative 3x. Negative 1 times negative 2 is a positive 2. Distribute the negative. 3x and negative 3x will cancel. 4 minus 2 is 2 as our remainder. And so we see right here, this is how we will write that answer. 2x squared plus x minus 1 plus 2 over what we were dividing by, which was 3x minus 2.
Could you just scroll up to the first problem just for a second? After everybody's done, after everyone's done with this.
So you talking about the first problem we did, or just the original?
Yeah, I just want to see the rough draft on the right side. I just want to copy that part, like where you did here. That
Yeah.
one.
All right, let me see. Try to see if everybody, is that too small for everybody? Can y'all see that?
That's good.
Yeah, make sure everybody.
All right, I'm good. Thanks, Professor Tucker.
All right, not a problem. Sometimes we forget about this option of minimizing and maximizing the screen. Yep. Everybody's done with those two problems before we look at another one. Make sure we're all right. All right. Let's go to the next one. So let me erase some of the stuff. I'll put it back, but I just want to give us a clean look at what the problem is. So we have x to the 5th plus x cubed minus 2. And we're dividing that by x minus 1. All right. So what we notice here is that we have missing terms. And so we'll need placeholders for those missing terms. And so what we're missing here is x to the 4th, x squared, and x. All right, so let me erase this stuff. All right, so before we get going, you're talking about how we set it up. Notice we have these placeholders right here. X to the 4th is 0x to the 4th, 0x squared, and 0x. And so You know, like I said, the placeholders, 0 times anything is 0, so they don't add any value to our problem. Make sure you don't put x there, because remember, you put x, then there's a 1 in front of x. That's why you have to put 0x, you know, and 0x squared and 0 to x to the 4th. All right, let me erase this stuff. All right, so just like before, comparing first terms to each, and saying what times x will give me x to the 4th, I mean x to the 5th, which would be x to the 4th. Right? X to the 4th times x, so x to the 5th, x to the 4th times -1 is negative x to the 4th. Distribute the negative. All right, so 0x to the 4th plus x to the 4th is x to the 4th. Bring down x cubed. What times x will give me x to the 4th? It's going to be x cubed. Once again, you're taking this x cubed, multiply it to each term on the outside. So x cubed times x to the 4th, x cubed times x is going to give me x to the 4th. Let me get it out. X cubed times -1 is negative x cubed. Once again, this minus sign needs to go to both. That'll be a plus right there. X to the 4th canceled. But now we have x cubed plus x cubed, which would be 2x cubed. Bring down our 0x squared placeholder. All right. So what times x will give me 2x cubed? That will be 2x squared. Multiply that to both terms on the outside. 2x cubed minus 2x squared. Distribute that negative. That'll be a plus right here. 2x cubed cancel. So that'll be a positive 2x squared plus 0x. So you see how the placeholders allows us to easily or continue to step through our process, you know, step by step. Then you say what times x will give me 2x squared, and that will be 2x. 2x times x, 2x squared, 2x times -1 is negative 2x. Once again, we're going to distribute. Almost finished though. 2x squareds cancel. Then you say what times x will give me 2x, and that will be 2. Multiply the 2 to the x is 2x. And then 2 times -1 is -2. And you notice that each one of our terms will cancel out, leaving us a remainder of 0. So this right here would be the answer. X to the 4th plus x cubed plus 2x squared plus 2x plus 2. And we don't have a remainder.
Professor Tucker,
Yes, sir.
I just want to make sure I got something real quick. It just hit me while I was looking at the problem.
Mm-hmm.
So basically, you put your equation in descending order.
Mm-hmm.
And wherever, if it's 5, it's 4, 3, 2, all the way down to 1.
Mm-hmm.
If you're missing anything in there, those placeholders.
Mm-hmm.
So I got it. All right.
All right. Anybody else before we look at synthetic division? So try this process out. Once again, if you have questions on anything, always feel free to you know, shoot that to me. And now it's real easy to miss a step. You know, these negatives get a lot of people a lot of the times. so make sure you're careful with that. All right. So next we have synthetic division, which is a little bit easier process. I don't say a little bit, it's a lot of it, but there's only certain times that you can actually use synthetic division. So we'll talk about that. Has everybody copied? Done copying? And I meant to bring this -2 down. I didn't write that arrow. Should have been an arrow there for -2, but yep. All right, so synthetic division. It's a type of division. It's not long division, of course. Long division is long division. So we can only use this though when our divisor is in this form. In other words, you see x minus c. So in other words, the coefficient of x is 1 and the highest exponent of x is 1. So if anything's different, you cannot use synthetic division in that problem. So looking at this first one right here, notice that's x plus 2. I can use synthetic division. It fits this form of x minus c. All right, so it's not about that minus sign. It's about your x having the coefficient of 1 and the exponent of 1. So now this second one, we cannot use it because we have x squared. And in this third one, we cannot use synthetic division because we have a 2 in front of x. All right, so if you have anything attached to your x that's not 1, then you cannot use synthetic division. All right. So let me erase this. Let's go ahead and use it.
Could you hold on a second, Professor Tucker?
Mm-hmm. Oh, somebody said something in the chat. Brimmer, hopefully, and I just saw this. Is that what you needed? Okay, cool. All right. Not a problem, not a problem. Oh, okay.
We could have used synthetic division in the first problem we did, right?
Yes.
In the first problem we did like a couple of, yeah, we could have used synthetic. Okay, I got you.
Yep, yep. Yep. So certain problems, you would have the option of doing long division or synthetic. Let's say if you're doing them on your own, you're trying to figure out doing research or whatever, as long as it fit that form, then you can do synthetic division.
Gotcha.
All right, are we good to go? All right, straight. All right, so let's try the synthetic process out. So we're looking at x minus 3. We're dividing that into x cubed plus 4x squared minus 5x plus 5. All right, so that's the problem right there. First step of the process, we want to recognize that if it's written in this form of x minus 3, we want to use the opposite sign. And what we're leaning on is the thought process of x minus 3 equal to 0. When we have that, what we would do is add 3 to both sides, and we will have the solution of x equal to 3. That's what that thought process is leaning on. We'll talk more about that later, but that's why we're using opposite signs. So if it's with x like this, you're always going to use the opposite sign of your number. All right, and we put that in this box right here. Let me erase this other stuff so we can walk through the process.
So if it's plus, then we use minus, right?
Yep.
Okay. Thank you.
Yeah, not a problem. Yeah. All right, and then also we use our coefficients here. That's what we're using right here. So that's where I got those numbers from. 1, 4, negative 5, and 5. So that's your initial setup. Right here is the initial setup of your synthetic division. If it's with x like this, written in this form, you use the opposite sign of that number, and you use the coefficients. So now the first move is to bring down, I guess I'll go purple. Bring down positive 1. Whatever this number is, you always bring it down. That's always the first move. Then I'm going to multiply this 3 times that 1. Whatever the result is, I'm going to put it right here. So 1 times 3 is 3. Then from there, we're going to add that. That'll be 7. And then you repeat that process. 3 times 7 is 21. Put that right here. Add these numbers. Negative 5 plus 21 is 16. 3 times 16 is 48. Add those together. That's 53. And your last number is always your remainder. All right, so remember the first thing you do is bring down the first number. Then you multiply the number in the box to that first number. Then add the numbers, we'll bring it up here and add those numbers together. 4 plus 3 is 7. Repeat the process of multiplication. 3 times 7 is 21. Add those numbers, get 16. 3 times 16 is 48. Add those numbers to get 53 as your remainder. All right. So now to finish it off, you're going to start with an exponent less, one exponent less than the original polynomial. So our original was x cubed. So we're going to start with x squared, and we use these as our coefficients. So that's x squared plus 7x plus 16. And then that's 53 over what we were dividing by, which was x minus 3. And that's a synthetic division process. All right, questions on that before we do another one? All right, gonna scroll up. All right, so let's look at another one. We have 5x cubed plus 6x plus 8. We're going to divide that by x plus 2. All right, so 5x cubed, first thing we recognize, we have 5x cubed plus 6x, so we're missing a term. We're missing x squared, so we have to use those placeholders again. We just use it for x squared, that's why we have that 0 there. 5068, right here, 5068, put a 0 in for x squared term, that x squared term. And once again, we're using the opposite sign, because once again, we're leaning on this thought process of if I had x plus 2 equal to 0, if I were to solve this, I would be left with x equal to negative 2, and that's what we're using down here in our synthetic division. All right. I could have that. All right, so let's go through the process. First thing we'll do is bring down 5. Then we're going to multiply negative 2 times 5. That result is negative 10. Add those together. That is negative 10. Negative 2 times negative 10. Positive 20. Add those together. We get 26. Negative 2 times 26. Negative 52. Then finish it off by adding those together. That'll give me negative 44. And we see that's our answer. Start off with one exponent less than what we originally had. We started off with x cubed. So then it means our answer should start with x squared. So 5x squared minus 10x plus 26 plus negative 44 over x plus 2. So notice I put my negative in the numerator with the 44. You could have wrote minus 44 over x plus 2. But this is always the safest way to write your answer, especially when you start having, and I'm not sure you guys will get a remainder like that, but when you have a remainder that has more than one term, you know, writing it up here and writing all the signs up there is the safest way to create a better, the best practice to create. I'll say it like that. All right, questions? Any questions? This is going to take us into the remainder theorem. Still going to be doing synthetic division, but introducing, like I said, the remainder theorem. So the remainder theorem, if the polynomial f of x is divided by x minus c, the remainder is f of c. So in other words, if you take c, now notice, once again, notice that opposite thing. Here, you have x minus c, but here you have positive c. So you're talking about plugging in the opposite number. You know, opposite number. Once again, that goes back to the idea. If I have x minus 2, I will have the opposite number as my solution. Remember, all of that's going to come back to play. So you plug c into the function, then that will be the remainder. Also, when you do synthetic division, your remainder is that last number that you have. All right. So given that f of x is equal to x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. So we're gonna do synthetic division, then we're gonna plug in 2 to f, and if the remainder theorem is true, then both of those answers should be correct. All right. I mean, not correct, both of those answers should be the same. All right. So notice what we did here. Let me erase some of this stuff. All right. So they give us f of 2. And notice I use the 2 that they gave me. The only time you use opposite is if they give you an answer in this form. So, and that's what I was emphasizing right here. If they give you x minus 2, that means it's the opposite. If they give you x plus 2, you will use the opposite. And so the only time, once again, you use the opposite if they give it to you as x plus something or x minus something. That's when you're looking to use the opposite. But if they just give you the number, like in this case, you just use the number that they give you. All right. So once again, using these coefficients, 1, -4, 5, and 3. And we'll just go through the synthetic division process. Bring down 1, multiply this 2 to the 1, and that'll be 2. Add those together. That'll be -2. 2 times -2 is -4. Add those together, we get 1. 2 times 1 is 2. Add those together, we get 5. So our remainder is 5. So if the remainder theorem is correct, if I were to take 2 and plug it into my function, this is my function right here, then I should get out 5 as well. And so that's what I did right here. Took 2, plug it into F, and you see we got 5. So that's going to be important as we continue to move on, using our remainder theorem and synthetic division. And define these remainders and establish whether we have certain types of numbers or not. All right, any questions? All right, another thing I want us to make sure we're okay with before we get into the next thing is that solutions, zeros, roots are all the same thing. They're just another word for solutions. So the reason why the word zeros is important is because your solution is a zero, but the reason why it's called a zero, from what I can ascertain, is that your remainder is 0. All right. So your remainder will be 0. That's what's going to take us into the factor theorem. So your solutions are zeros because when you take it through the synthetic division process or use the remainder theorem, you will get 0. So that's what the factor theorem states. Let f of x be a polynomial. So f of c, if f of c is equal to 0, then it means x minus c is a factor of f of x. We'll talk about what a factor means in a second. But then if x minus c is a factor of f of x, then f of c is equal to 0. So it's just saying that, you talk about these factors. If it's a factor, or in other words, if it provides a solution, the result is going to be 0, whether you divide it out and get your remainder or you plug it into your equation. Anybody holding on to that top part? All right. So what's a factor? Just in case you haven't seen it before or using that way, when you're talking about x squared plus 7x plus 10, when you factor it out, the results are your factors. So x plus 5 and x plus 2 are your factors. All right. And so, the rest of the process, we've already talked about that in previous sections. You'll set x plus 5 equal to 0 and x plus 2 equal to 0, solve them out. And then there are your solutions. Once again, when it's with x, it was plus 5, but when you have your solutions, it's negative 5. That goes back to what I was saying about the opposite number. Your solution will be the opposite number. Same thing with x plus 2 gave us x negative 2, x equal to negative 2 as our solution. And once again, those solutions are called zeros. All right. Make sure we're okay. Make sure we're okay with why all of these things connect. Oh, I just thought about something. While you guys are copying that, let me make sure I didn't leave something on in the kitchen. Hold on a second. All right, we good to go. All right. Can I scroll up? Everybody good? Oh, also what I was emphasizing down here is that when you take that -5 and plug it into the equation, you get 0 out. That leans back towards what we're saying here. So, and that's what we talked about before, right? That's how you check to see if you have a solution, plugging in those values, getting 0. All right, so first exercise under this thought process, they want us to solve the equation. Let me erase some of this stuff and then we'll talk about it. All right, so he wants to solve the equation. Give 2x cubed minus 3x squared minus 11x plus 6. And given that 3 is a 0. 3 is a 0. All right, so before we get started with this, there's certain things I do want to point out. Let me put it back up here. Oh, my stuff go. There we go. So we're going to have 3 solutions. Highest exponent of x is 3, or highest exponent on our variable is 3, so we should get 3 solutions. And 3 is a solution. It says 3 is 0, that means 3 is a solution. That means when I plug 3 into the function, I get 0. And that means x minus 3 is one of our factors. Remember I said using the opposite sign when you plug it or use it with the x. So x minus 3 is a factor. 3 is a solution. And when I plug 3 into my function, I should get 0 out. That also means when I do synthetic division, the remainder is going to be 0. Let me erase this. I could have left that. All right, so you always want to make sure you use the directions to your benefit. Make sure if there's any clues or hints as to how something should go down, that you let the work for you. And what I mean by that is that we know that 3 is a solution. 3 is a 0. So what has to work or what has to happen is that the remainder is 0. If the remainder is 0, that means the last number that should be produced is -6. So if that does not happen, somewhere you went wrong in your calculations, because it's not supposed to have any other result but that. Once again, they didn't ask us to, is 3 a 0 or is 3 a solution? They told us that that was the case. All right, so make sure you use the directions to your benefit. So you bring down 2. 3 times 2 is 6. Add these together, that'll be 3. 3 times 3 is 9. Add those together, you get -2. And 3 times -2 is the -6 that we needed to get 0 as our remainder. All right. So like I said right here, we're just using synthetic division to break down the function. So now we're going to solve the remaining equation. We start off with x squared. That's 2x squared plus 3x minus 2. Remember that our initial equation was x cubed, so we're starting with x squared. Now I'm going to factor this, but remember you always have the option of using the quadratic formula if you're not too comfortable with your factoring. So I factor this out to be 2x minus 1, x plus 2. Set both parts equal to 0. And there you have your 2 other solutions. Also, don't forget, x equal to 3 was a solution. If they ask you to write down all of your solutions and you leave out x equal to 3, or you leave out 3 as one of your solutions, they will mark it wrong, because that is one of the solutions, even though they gave it to you. So make sure you write down all of your solutions. All right. Questions, questions, questions. All right, can I scroll up? All right, so let's do another one. I want to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equal to 0, given that -1 is a 0. All right, so once again, we have a situation where we should get 3 solutions and they give us 1. So we're going to use that -1 to break down the polynomial or break down the equation. So 15, 14, -3, -2 will be our coefficients. You bring down your 15, -1 times 15. Oh, is -15. Add the 14 and -15, that'll be -1. -1 times -1 is +1. -3 plus 1 is -2. And -1 times -2 is +2. -2 plus 2 is 0. So remember, that had to happen because we knew that -1 was a solution. All right. Problem with that. They just didn't do it. Yeah. All right, so take 15, -1 and -2. Turn it into our quadratic equation. Start off with 1 degree less than what we had initially. So that's 15x squared minus x minus 2. Once again, I decided to factor. If you're not comfortable with factoring, or if it was a situation in which you could not factor, you would use a quadratic formula. So 5x minus 2 equal to 0, 3x plus 1 equal to 0. Have my two new solutions, 2 over 5 and -1 over 3. And don't forget, once again, that initial solution that it gave you of -1.
Professor Tucker,
Yes, sir.
just a question.
Mm-hmm.
Where it says given then -1 is a 0, what if it's not given? Like, it's like we have to find if it's like it's not given to us. Is it always going to be given to us?
That's next section, sir. Next section.
Next section. Okay.
Mm-hmm. Yep. Wherein what we'll do is we'll have a list of possible solutions, and you can go through testing them by plugging them in or doing synthetic division.
I got you. I appreciate it.
Not a problem. Not a problem. Good question. Good question. All right. Questions on anything that we've done up to this point? Make sure we're good. It was like 1:30. We got about 15 minutes. Let's see. Next section starts there. We can wait, I guess. We got chapter 3. Blah blah blah. Yeah, we can. I think that's enough to digest. Y'all got 3:1 and 3:2. Y'all just coming out of spring break, so I guess I had a little mercy today. So that's it for 3:3. Try the stuff out. See if you get stuck. You always can shoot me that email for questions and stuff like that, or get it on the back end of class, or front, depending on what's going on, and we'll go from there. Next class we'll look at 3:4, and we're gonna hit on what Mr. D was just mentioning. If you don't have any solutions, how do you go about trying to find your solutions? So, and we'll go from there. All right. Any questions, concerns before we close out? All right. So, you guys have a great weekend. Be safe, and I will see you on Monday.
Tucker.
Yes, sir.
3-2. Do we need to worry about that?
Not right now.
Okay.
Not right now. Yep.
All right, Professor. Thank you so much.
All right. Not a problem. Thank you. You have a good
Stay
one, sir.
safe.
Yep. You do the same. All right. Everybody take care.